We're now in a position to see what kinds of inferences we can make within predicate logic. We're going to introduce several rules here, and most of them have to do with quantifier introduction or quantifier elimination. So let's start with one of the simpler ones, the rule of universal instantiation. Suppose we're given the sentence, all roses are flowers. We will represent it in the following way. For any x, if x is an R, then x is an F, where R stands for the predicate is a rose, whereas F stands for the predicate is a flower. X, remember, is a variable which is a placeholder for an individual. Now, given that we're given this universal sentence, this means that if I pick any random object which happens to be a rose, I'll also know that object to be a flower. Let's say we call this object the object A. So then I can infer on the basis of what I'm given in the universal sentence that this individual A, given that it is a rose, it's also a flower. In this way, I am instantiating from a more general sentence to a sentence about a particular individual. Suppose that I picked at random another rose. Given my universal sentence, I would know that this one also is a flower. If I picked another one, I would also know that it's a flower. This tells me that any random object that I pick out of the universe of any possible objects, if it is a rose, it's also going to be a flower, which also means that I can represent that fact by using an unbound or free variable to represent the fact that any random object in the universe, even if it's not any particular one, if it ends up being a rose, it's also going to be a flower. This is to say that we can instantiate a universal sentence to a free variable in addition to instantiating it to a particular constant. Remember, the rule of instantiation lets us make inferences from general statements of classes of things to more particular statements of individuals.